always helpful. Good. Everything appears to be good. All right, so I'm going to open today. Hello. Welcome back with a deal. Here's my deal. It's time to play Let's Make a Deal. Course evaluations have been opened for the fall semester. You have about another week and a half to do them or so. They close, I believe, Saturday after classes. And here's my deal for folks. You can see how many people have completed an evaluation thus far in my 2 classes. If at least 26 out of 28 of you complete a course evaluation, then I will offer everyone in this class 1 point of extra credit, 1 percentage point added to your grade. Subsequent to that deal, later this afternoon you will receive an invitation to complete a custom Qualtrics survey as well, because the questions that are asked on the university evaluation are completely generic and not that useful. So I prefer to get more specific feedback, and I would like to compensate everyone for providing that more specific feedback. So the way it works is that each of your email addresses is inside the Qualtrics system. It keeps track of which emails have completed an evaluation, but it does not link your responses to your email, so it is still anonymous. Everyone who completes the Qualtrics evaluation will also get a point extra credit. So for the university one, I can't see who's done it and who hasn't, but as you can see, I have a little reminder button here that I can email people who haven't done it yet. So I will do that once or twice until they close, and I can do the same thing in Qualtrics.
Wait, they're not automatic?
I don't know which ones are automatic, but I do know this button right here allows me to email just the people who haven't done it yet, but I don't know who they are.
I got one at 12:15 last night, so
okay.
I was wondering who might be awake and sending a reminder.
It was not me. 12:15 does not exist in my life. If I'm awake at 12:15, it's because I've already been asleep for hours and I get up to go to the bathroom in the middle of the night. Like, that's 12:15 for me, okay? And yes, 12:15 is the middle of the night when you're this old. But, so, how's that deal sit with everyone? Fair? All right, I do value your feedback. I do make changes as a function of it. As an example of things that I have changed, once upon a time, the formative assessments used to be actual quizzes done for real points, like with the timer in class. The feedback on that was unilaterally negative. They absolutely hated it, so I quit doing it. So things like that, that I have control over. Some things I don't necessarily want to change because I do it in a certain way for a certain reason, but I always want to hear feedback as to other folks' ideas in terms of how I can meet my objectives better. It's always a work in progress. All right, so in terms of what is left for work in this class, you have a formative assessment due on Monday night that you can do at any time, where you get to help me address Reviewer 3's comments about measurement model analyses. We will talk about that on Tuesday. I also put up your last homework assignment. Homework 6 is available inside the homework portal. It is a series of invariance analyses, first using CFA models and then switching to IFA models. Because there are so many model comparisons, you have to use M+ for this one. I'm sorry. I can't make the numbers work in R for that. And rather than like force you to keep entering the same number with like added, one in the decimal place or whatever to fuss with it, like let's just not do that. So you can try to use R, but I can't guarantee that it's going to work. M+ I can guarantee will work. So that you can do at any point. We've covered everything we need for that, and I'm happy to answer questions as things come up. All work needs to be turned in by the end of finals week at 5 o'clock. So anything that is outstanding that you want help with, let me know, but otherwise that's the end of the show. So we can all have a winter break of sorts. Of sorts, I know. See, it's not really a break, it just means you're doing different work than you're doing now, but still different is good. All right, any questions on work, logistics, scheduling, any of that stuff? Good. Should we talk about higher order factor models? Big picture, what are they for? Why would you fit a higher order factor model?
One advantage is that you can use them to predict an outcome instead of having all the individual factors.
Yeah, so you can fit a higher order factor is, let me get a picture up here. the idea that we can think of lower order factors as indicators of what is known as a higher order factor or a second order factor. Those terms are synonymous. And that can represent the common variance among multiple factors more efficiently, so that that common variance itself could become a predictor or an outcome in another model. So this type of factor structure is commonly used for measures where there's multiple subscales, but all the subscales are supposed to be just like facets of one larger construct, more general construct. How many lower order factors do you need to make a higher order factor model testable? 4. If you only have 3, then what?
Just identify.
It's just identified. So if I only have 3 lower order factors, I can fit a higher order factor, but it will fit exactly the same as just letting the 3 factors have a covariance. So it's not testable even though it's estimable. So I'm swapping out essentially the 3 covariances for 3 loadings. And it's an even trade in that case. What if I only have 2?
We should constrain some parameters.
Yeah, if I only have 2 lower order factors, I can fit a higher order factor. So here's a picture of what that might look like on slide 8 of lecture 8. But then the loadings to the higher order factor would have to be equal to each other in order for it to be just identified and not under-identified. In other words, if you have 2 lower order factors, what you have essentially done is take their covariance, give it a name, and draw a circle around it. That's all it is. It's literally what is in common between the 2. Some people want to do that, but that's what it is. We talked about when these do and don't make sense. So a couple scenarios here. The presence of strong correlations among the lower order factors, I think, is a logical prerequisite. They have to have enough in common for it to make sense to represent that common variance as its own factor. If they're not correlated, that will show up as higher order factor loadings that are quite small, in which case then whatever this construct is ambiguous because there's not that much in common. So it becomes difficult to justify theoretically. Yes, sir?
If the covariance across factors is high, how can we know that they are not the same thing?
Because it's a testable hypothesis whether you need 1 factor or 2 factor or 3 factors. And it boils down to whether the correlation among your lower order factors is different than 1. So if you fit a single factor model and you compare it to a 2 factor model, that's different by 1 parameter because you're allowing a covariance to be less than 1. Another way to think about it is that the covariance would be perfect in the 1 factor model.
Okay.
If you go from 1 factor to 3 factors, then that's 3 degrees of freedom because you have 3 covariances now that you're allowing each of them to be different than 1.
Okay.
Yep. But in the same way that when we started looking at items forming measurement models and we stared at correlation matrices, do you remember that? And I asked you to do that in your homework. And you can kind of tell what's going to happen based on that. The same logic occurs. In the example that we're going to follow, we're going to first look at the correlation among these 5 factors and try to get a sense as to whether it's a reasonable thing to even ask if there's a higher order relationship. The correlations will tell you quite a bit about how well that's going to work. And ultimately, those are the correlations that the higher order factor is trying to recreate. All right. Questions so far, or things you want to talk about? Or type about, Zoomers. I'm watching the chat window as usual. Typing is talking. All right. Then let's head back to my example here. The story here, these are real data. These are responses from your standard Intro to Psychology subject pool about 5 different ways that their parents could have been mean to them. So even though this is a 5 response option item format, these are really skewed because most of these people did not have mean and terrible parents do mean things to them. So I'm showing what this would look like using CFA estimated using robust maximum likelihood and using IFA models estimated using WLSMV. My purpose in showing these to you is not to compare across. I'm not trying to say that like CFA is better than IFA or vice versa. My purpose is really just to provide you with two different examples. That way you have one for each situation, but also to illustrate just how similar the process looks, because when we get up to the structural level, everything is a continuous latent variable. So at the structural level, when we're talking about higher order factors and lower order factors and all that stuff, it's a functionally CFA because everything's continuous. So the measurement model part is really where the distinction lies between traditional CFA and IFA. WLSMV is probably the only way to go in this case because this model is eventually going to have 6 factors, a higher order factor and 5 lower order factors. Can you think what would happen if I had tried to estimate it using marginal maximum likelihood instead, using full information? How well is that going to go with 6 factors in the same model? Not well. So if I'm using marginal maximum likelihood, I'm using adaptive quadrature numeric integration, where I would have 15 to the power of 6 dimension of integration points, 15 per dimension. I don't know what 15 to the 6th is, but it's a lot. So it would take a very long time to converge, potentially not even converge. So that's the point at which switching to limited information can be helpful, or even switching to Bayes, which is not this class, that's tomorrow. I only have room to do so much. So what happened behind the scenes then in this example is that I first fit separate measurement models to the items for each of these to see how well those held together. That process then resulted in some of the initial pool of items not being included because they did not load on their hypothesized factors. There are a different number of items per factor in each of these two, so there's a little bit of unevenness with respect to how well some of these are going to be measured. For instance, the isolating factor only has 6 items, whereas the ignoring factor has 15. I would expect, just based on that there's greater reliability for the 15-item factor than the 6-item factor. So we had looked at that briefly last time. We also looked at the straw man model, a term that means a point of comparison that you don't really think is going to work, but you're using it just to make that point. Because the authors of this scale had hypothesized this as sort of a unidimensional, like, this is child maltreatment, and then here are 5 specific ways that you can have maltreatment towards your child. So this is trying to either support or refute the argument that we're measuring one thing. So the trick that allows you to keep the code that you had written for your 5 factors and not have to rewrite it is to choose the z-score factor method of identification. So all the variances fixed to 1, all the means fixed to 0. That means that all of the factor covariances become correlations. So this code right here forces them all to be 1, which is another way of saying this is a 1-factor model. If all 5 factors are perfectly correlated, that is a single dimension instead of 5. So that model did not fit well. It will be one of our points of comparison for alternative models. So then we look at the actual 5-factor model. So the difference between the previous code and this one is that I have replaced the @1s with stars. So that's just explicitly representing the fact that now we're estimating the separate covariances. So that those covariances are interpretable directly as correlations, I'm still keeping my method of z-score factor identification for now. Variances fixed to 1, means fixed to 0. And I can do a likelihood ratio test against the previous model. So relative to the single factor model, the difference in -2 rescaled log likelihood is 600 and some odd. For 10 degrees of freedom, where did the 10 come from? If I'm comparing a single factor model to a 5-factor model, that's different by 10 parameters. What are they? Yep, that's the all possible covariances among the 5 factors. There's 10 of them. So I'm allowing them to be something less than perfect, essentially, with this approach. So beyond just demonstrating that I need 5 factors as a better fit than 1 factor, or 2 or 3 or 4, this is essentially my new answer key with respect to the structural model. This is as good as it gets, because I'm not trying to recreate the factor covariances with higher order loadings yet. I'm just seeing what they are. So the structural model is saturated. There's nothing else that could be added to it. I've spent all the degrees of freedom. And the way that you can figure that out is the number of variances and covariances of your factors. Essentially, those are all possible of those have been estimated. Here is the correlation matrix among my factors with my typical color coding that I like to do in Excel. So what do you think about this? Does this look like all of these lower order factors are correlated to the same extent, more or less? Not so much. So I see certainly spurning, terrorizing, isolating, so like that. Those look pretty good. Ignoring looks like it kind of wants to be part of that story. But corrupting, that one looks different. Corrupting doesn't really look like it wants to play ball with the others as much. It's more related to terrorizing, but it's less related to the other things. Corrupting, by the way, is stuff like letting your kids drink and smoke in front of you, like encouraging their bad behavior, which is a different kind of terrible than being actively mean to them, abusive, and so forth. But allowing your children to do bad things, also not ideal. So this is the pattern that the higher order factor loadings is trying to recreate. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means if I fit a higher order factor and replace these 10 covariances with 5 loadings, I will have saved 5 degrees of freedom. So a higher order factor model is actually simpler in terms of estimated parameters. It's trying to recreate these 10 covariances with 5 loadings. In the same way that in a measurement model, all of the item covariances are being recreated by the lower order factor loadings. Unfortunately, this model doesn't fit that great by some of our standards. And yes, it is common that they will disagree. So 157 parameters is what I've estimated here. I've got the count down here. I got 49 loadings, 49 intercepts, 49 residuals, 0 factor variances, 10 factor covariances, and 159. So there's 49 items that are going into this analysis. In terms of chi-square test of model fit, what's this one telling me? Worse than perfect. So this is my model against every possible item variance, mean, and covariance being recreated. So worse than perfect, definitely. RMSEA, what's this telling me? Good or bad?
Good.
Good. So this is a non-significant result that's good. It means we do not reject the idea that it's less than 0.05. It is less than 0.05. Even the confidence interval, the whole thing is less than 0.05. So RMSEA is a parsimony-weighted index. It will be happier to the extent that you have a lot of degrees of freedom left over. To be specific, I have over 1,000 degrees of freedom left over. So this is a relatively parsimonious model. The width of your confidence interval, by the way, is going to be a function of your sample size. The more people you have, the more precision you have to figure out just how badly your model fits. How about CFI and TLI? They're not happy. But they're judging a different standard, right? They're relative to the worst model. How much better is your model than the worst model, where the worst model has all the means and variances but no covariances at all? SRMR is worse than perfect. So this one is relatively happy as well. This is the average offness and correlation between the data and the model for the items. So most of the degrees of freedom, actually all of the degrees of freedom in this model are from the measurement model. The structural model is saturated, and so that's why this is a baseline to compare simpler models that specify higher order factors instead. So let's see what that would look like. To keep the code onto one page of a handout, what's not included are all of the individual item intercepts and all the individual item residual variances. Those get estimated by default. You don't actually have to type them. So I have deliberately changed the method of identification for this model. What do I call it if I have the first loading fixed to 1?
Item markers.
Yeah, that's the marker loading is the term that gets used in your textbook. This is the default in most software, by the way, for SEM. So I am fixing the first item's loading to 1. As long as that item has a loading that's non-zero, that should be fine. Otherwise, that won't work. Because I have identified the model so that my loadings are fixed to 1 for the first item, that means I free up my factor variances. So it's either or, but not both. If I forget that step, if I fix these to 1 and the first loading to 1, that's the same as saying the first item is perfect. All factor, nothing else. Unlikely. The factor means, by the way, are still fixed to 0. So we're estimating all of the item intercepts, leaving all of that information down in the measurement model. These factor variances, though, are going to become what's known as disturbances because it's factor variance left over after being predicted by the higher order factor. So that is the new part, which looks exactly like you might predict. Here's my higher order factor. I've called it abuse because maltreatment was too many letters. And these are my lower order factors. So rather than referring to individual columns of items, I'm referring to the names that I gave them up here. So I think there's probably an order of operations, like you have to define the factor before you can use it in the higher order factor. So I would build like from the ground up, so to speak. But the higher order factor here, I am fixing its variance to 1 to identify it, its mean to 0, and all of the higher order factor loadings are being estimated. So this is technically a nested model relative to the 5-factor correlation model because what's not here anymore that used to be in the code? What's missing? I'll scroll back. Before. Yeah. After. Yeah, the covariances are gone. What happens if you leave them in?
We would assume they are perfect.
It won't be estimable. You'll be under-identified. Because you can't have 5 loadings to recreate all the covariances and all the covariances too. They're redundant. So you'll get a few of them, but the others will be zeroed out, or you'll just get an error message where M+ is like, no. By the way, you'll know that your model did not estimate if all you get are estimates and no standard errors or test statistics. Like if you just get a row of numbers, like a column of numbers, it didn't work. Okay, so let's go over here. Fit, still worse than perfect. RMSEA is still pretty happy with me. CFI and TLI are still not happy with me. SRMR is happy with me.
I have a quick question about
Yep.
sample size and the chi-square stuff.
Mm-hmm.
Mainly because the sample that I was using in my thing was like 4,000 respondents. So like
Yep.
I have lots of power.
Yep.
But I'm curious, like, what is kind of, I'm looking for general guidelines, right? So like obviously for me it was like, yes, this is a sample size. I highly doubt I will not have a not significant chi-square.
Mm-hmm. At what point do you believe in it? Is that the...
Yeah, or like make that claim that like it's because of my sample size.
That's a tricky one. So the question was, like, yes, we expect the chi-square for model fit to be significant anytime you have a large sample, which means you have a lot of power to detect small differences. Where does large start for your sample? I can tell you that in simulation studies on the behavior of structural equation models, the smallest they would consider is like 200 people. Like, that's small. So I think large starts somewhere around like 3,000 or so. Like, it's, yeah. But more to the point, like, you have 1,100 degrees of freedom. Like, there's no way that that's going to be perfect. Like, it's not, that's not even a reasonable goal. The question is, like, how far off are you? And then it depends on what your definition of, like, off is. But here's the thing. Had I not fit that previous model, I would think this is fine, right? At least these aren't fine, but this certainly is. And I'd be like, look, I have a higher order factor. See, it fit. But that's not true. Most of this information in terms of the fit is coming from the measurement model. That's all of it. The structural model, actually, we can't tell how well the structural model fits from this output. Because it's not zeroing in on the section that we modified. To do that, we got to do our own likelihood ratio test. So relative to the previous model, in which we had 10 covariances among the lower order factors, now I have replaced those covariances with 5 higher order loadings, and the difference is 46. So I could either say the original 5 correlated factor model fits significantly better, or I could say the higher order factor model fits significantly worse. You can spin it from either direction. But the higher order factor model is not better. It can only be worse or not worse, because it's a simplification. But I don't want to just take my ball and go home. I got to figure out why. So here's my higher order factor loadings. This is the standardized solution for them, in which these are correlations. So these all look pretty good. The higher order factor is being driven primarily by the first 3. Corrupting is the lowest, but 0.7 is still pretty good. So it's not like any one of these is a complete dud with respect to being correlated with the others. But we can go to the modification indices to see what they have to say as to how we could make the structural model better. So I have just shown you the parts of that that are relevant. So here is the saturated version of the model. These are the correlations that we just looked at among the 5 factors. This is the version that is predicted by the higher order factors. So this second correlation matrix is the model implied relationship between the lower order factors that the higher order loadings created. I got that piece of output, by the way, I think I forgot to mention this, with this right here, Tech 4 on the output. There's actually Tech 1 through 19, I think. They're up to 19 techs.
How do you struggle with their names? Like,
you know. Job security, that's why.
yeah.
I know.
Sounds
But
like inaccessibility to me.
that too. Well, you know, if the M+ manual were perfectly understandable, I would not have a job. So I have a vested interest in them continuing to be obtuse and difficult. I do wish I could get a kickback, though, because I'm constantly training new people to buy their software, right? Like, I feel like I'm kind of working for them in an inadvertent sort of way.
Lisa,
Yeah, Tech 4, though. That's where that came from.
what are the things we are correlating here? The factor scores?
Nope, everything's in latent space. So we are not outputting thetas or factor scores of any kind. We are estimating directly the relationships among the factors that the higher order loadings imply. So like the correlations, if we look for, where'd that go? So the predicted correlation between spurning and terrorizing is that number times that number. Go up to the thing, come back down.
Okay.
The correlation that is predicted by the higher order factor between spurning and ignoring is that one times that one.
Okay.
And as long as we have fewer higher order loadings than we have covariances, it's over-identified. So if you have 3 lower order factors, that's 3 loadings, that's just identified. If you have 4, then there's 6 covariances versus 4 loadings. If you have 5, then there's 10 covariances versus 5 loadings. And it keeps going from there. So this is the right answer. The first correlation came from just let the 5 factors be correlated. Don't put any structure on them. That's the best answer in terms of the structural model. That's saturated. This is what is predicted by the higher order factor. And then I literally computed the difference. 0.929 minus 0.25 is 0.04. So M+ calls these like residuals for correlations or residuals for covariances. They are discrepancies. So the correlation between spurning and terrorizing, pretty close. The correlation of spurning with everything is pretty close. It's terrorizing with corrupting and terrorizing with ignoring are the ones that are a little bit off. But not by much. 0.08, 0.04. We have a lot of power in this thing.
Lisa?
Yeah,
I have 2 questions.
sure.
What's the meaning of the new factor loadings?
The new factor loadings,
Yeah, how they affect the lower order factors? Or what can we say about those factor loadings? They are positive, right?
Mhm.
But are they bounded between 0 and 1?
this is the standardized solution, and so those are.
So yeah, okay.
The unstandardized solution, I don't think I put in here, but they're not bounded. I mean, they would be in the scale of what the variability of the lower factors was estimated to be. So they're scaled relative to what the outcome is,
Okay.
which is the lower order factor. The
Um,
predictor has a standard deviation of 1 because we fixed that.
Yeah. What's the meaning of those standardized numbers? Just it is a measure of correlation, a
Yes.
measure of some kind of effect size?
Yes, yes.
Okay.
In the same way that the standardized loadings were the correlation of the factor with the item, these are the correlation of the higher order factor with the lower order factor.
So the interpretation is if they are more or less correlated with the higher order factor.
Mhm.
Okay. The second one is, can we compute some kind of indirect effect between the higher order factor and the item using the factor loadings?
Yes. So if we wanted to figure out like what the predicted correlation is between 2 items, then yeah, we would go all the way up and come back down. So the higher order factor allows the items from the same factor to be more related, essentially, than items from different factors. But items from different factors are related by going up through the loading and coming back down. In the same way that we would go up to the factor, over to the covariance, and come back down. It's the exact same idea.
Okay.
So the standardized solution then is, what if we took each of the lower order factors and gave them a mean 0, variance 1? And if we took the higher order factors, the predictor, and did variance 1 on it, then these are in a correlation metric. So they have to stay within bounds of plus or minus 1. These are all positively related because these are all scored such that higher values mean more maltreatment. Okay. Other questions? Zoomers, you got anything for me? It's a quiet group today. It's all right. I understand. So in terms of where the structural model is off, it's these 2 relationships that are relatively biggest. And lo and behold, that's what the modification indices are picking up on. So this table means, hey, if you allow for an extra relationship between terrorizing and corrupting, your chi-square is going to get better by 44, and that residual correlation would be 0.59. And if you allow for an extra relationship between ignoring and terrorizing, that's how much your model chi-square would improve by, and this is what it would be. It would be negative. So ignoring and terrorizing has a negative discrepancy. So it's trying to solve the fact that they are less related than predicted by having a negative correlation between them. It's literally like plugging a hole. These 2 are more related than the model predicts, And so M plus is like, all right, I'll give you a positive correlation. We'll fix that one right up too. Well, not M plus per se, the algorithm, right? Lavon gives you the same information, but in the current version of Lavon, it gives you the modification index for the non-robust chi-square, not the one that we're using, which means the numbers don't match. They should at least be like in the same rank order, but I can't guarantee that. So based on these two things, I decided to add in those extra relationships. So I put back just those two covariances. So now I'm trying to recreate 10 lower level factor covariances using 5 loadings and 2 residual covariances. That means I'm still saving 3 parameters. Here's the predicted result of that model, and here are the discrepancies. So now all of the correlations are off by less than 0.01 in a correlation metric, which is really good. So there are 2 model comparisons that I could do. Does adding the covariances help? Yes, it does. So we do need them. And the modification indices are like, duh, I already told you that. But just to prove that they're right. The other one is this model now not worse than just letting the 10 covariances be whatever they want? And the answer to that with 3 degrees of freedom is it is not worse. So now I have evidence for a higher order factor, but only after adding in 2 residual relationships. So the 2 corrupting and terrorizing have something else that they're related to that's not maltreatment. Don't know what that is. Ignoring and terrorizing have something else that's related to them, but it's backwards. And I don't know what that is either. So error covariances like this, disturbance covariances, are unplanned for and uninterpreted multidimensionality. I don't know why these need to be here. I know that they do.
So when we were talking about like item level residual error covariances.
Mm-hmm. Error covariances, yep.
Thank you.
Mm-hmm.
You said for the most part, like, you want to kind of avoid those, use those sparingly, all that sort of stuff.
Yep.
Is it kind of the same thing with the disturbances?
Yes.
Okay.
Yes. So the question was, generally error covariances need to be very well defended, predictable, explainable, etc. You would have to add a caveat to your discussion section saying they need to be replicated in subsequent research on a new sample, because we've crossed over from what is purely confirmatory to using our data to refine our model, which is kind of back into exploratory mode a little bit. It's not an exploratory factor analysis because we're staying within a confirmatory framework, but we are messing with it. And such modifications need to be defendable and replicable, especially the case here because there's only 5. So there's fewer ones that I could even add, I think. But the same is true, like if you end up with several, like if there were 3 of them that all wanted to be together, then that would probably point to those 3 breaking off onto its own higher order factor, and then like a 3 and a 2 kind of thing. You could do that instead. Yep. So
I'm
here,
sorry, in this
yeah, go ahead.
example, I have a question.
Sure.
Did we establish that the lower order factors behaved the way we expected them to?
Yes.
Okay, thank you.
Yes, the fit was not great, but I didn't expect it to be because there's a sense in which this model is probably not appropriate for these data because it's a linear factor model to 5-point responses that are positively skewed.
Okay.
By the way, I know that indirectly because of the scaling factors. So the scaling factors that go with the robust correction are really big for this. Like, there's supposed to be 1 if everything's perfectly multivariate normal, and 2.5 is, like, big. I don't know what the scale is, I just know that's really big for, like, relative to the models that I've seen. Question, but you cannot explain them here. Is it still okay to add them? Referring to the disturbance correlations or the error correlations, like, I would be careful. I think that I don't have the content knowledge regarding these items and this subject matter to say why they could be related or not related. I'm just purely going from a data-driven, this is the problem and I fixed it. Whether that fix is a reasonable thing, whether a different fix might be as well-fitting but maybe more defendable, I don't know. So yes, you should be cautious in adding such things. Yeah.
Lisa?
Yes, lots of
So-
questions today.
In page 6.
Page
when-
6.
Yeah, when you add the covariances between factors.
Yes. So right
yeah.
there. Yep.
Can you repeat why did you do that between ignore with terror if the residual is negative? So in the data set they were less related than we estimated. Than the model estimated.
They were less related in the saturated structural model than the higher order factor predicted. But they're not in the data set because these are all latent things.
Yeah.
The reason I picked these two is because here is the correlation among the factors if you just let it be whatever it wants. Here is what the higher order factor says it should be by multiplying the standardized loadings together. And I computed the discrepancy of observed minus predicted. And these are the two that were relatively largest. So terror and corrupting, that correlation was underestimated by 0.08. They're more related than what the model says they should be. Ignoring and terror was less related than what the model says they should be. And those discrepancies are literally what these are trying to fix. So the local fit information is telling you what the problem is. The modification indices are telling you ways to fix it.
Okay. So both, regardless of the sign, positive or negative, both can be fixed with an error covariance.
Yes.
Okay, great.
But it gets trickier. So like the positive one, it's like, well, there's something that corrupting and terrorizing have in common that is beyond maltreatment. And if because I have a PhD technically in psychology, I'm going to make some shit up. Is that all right? Corrupting and terrorizing are both actions. Like you're doing something to your kid as opposed to just ignoring them. Whereas like spurring them is like, get lost, go make yourself dinner, I'm busy. Like that's like a passive, like a lack of stuff versus like, that's my armchair explanation. How's that? Seem reasonable? Yeah, so it's like if you're lazy and you want to be mean, that's one set of strategies. But if you want to put effort into being mean, that's a different set of strategies. But ignoring and terrorizing, yeah, I mean, if you look at it from that lens, they are kind of the opposite of each other because ignoring them is lack of effort and terrorizing them is effort. So I probably shouldn't joke about child maltreatment, but it's a good thing the responses are positively skewed. Can I say that, at least? Most of the people in the sample did not have terrible things happen to them. Oh, one of the Zoomers is going to agree. Active versus passive. Yep. Yeah, there's like neglect versus abuse, kind of, is the thing. So I think if you wanted to try to divide these into passive versus active ways of being mean, that might make a more theoretically sound designation than just plugging in the holes in the covariance matrix with these disturbance relationships. All right, how are we doing? So point of the story, if you fit a higher order factor model, you can't just look at global model fit to see if you like it. It has to be compared to a saturated structural model because that is what the higher order factor is doing. Most of the model fit degrees of freedom are from the measurement model. And so you cannot tell if the structural model fits just by looking at one set of fit indices. Model comparisons relative to a new answer key in which all factor covariances are estimated first. As a general operating principle, that should be your first model. Because then you can put in whatever higher order factors or regression slopes instead of correlations or whatever you want to do with your factors But knowing how well they relate to each other in the first place then hopefully would inform the results subsequently after you put in the version that you want for their relationships. All right. So here's some words. Everything I just said, my results section, including all the model comparisons put in there. To do the same thing in WLSMV, the only difference, categorical option. Estimator equals WLSMV, parameterization equals theta. By the way, there's two parameterizations. There's delta and there's theta. They differ in how they scale the pretend underlying variable that is part of this limited information process. Delta says that the total items variance is 1. Theta says the residual variance is 1 instead, and the total would be more than 1. So the theta parameterization directly corresponds to a probit link, which is why I use it. That is not the default in M+, and I don't think it's the default in Levon either. So just be aware that if you don't have this, then your results are on a different scale potentially than what you're thinking that they might be. Model comparisons are done via diff test. This is not directly built into Levon, but the ANOVA function approximates it, but not close enough to use for the homework. Otherwise, it is exactly the same. So here is the fit of the, let's see, this is the 5-factor model. TLI and CFI and TLI are much happier, by the way. RMSEA is less happy. So you can't win them all in the WLSMV version of the model. We did have to estimate a whole lot of thresholds, so that's partly why it's not going to be as happy. Single factor model doesn't fit very well according to chi-square for difference testing. So the 10 correlations among my factors are not perfectly one. The code for the higher order factor model looks exactly the same as if you're doing MLR, because this part of the model, these are all continuous variables. It doesn't matter what kind of measurement model you have. The structural model is the same either way. The only catch is remembering to ask for your model comparisons via diff test, saving the results of this model, comparing against the previous 5-factor model is the answer key. Same conclusion though, the higher order factor fits significantly worse. Okay. Corrupt has a slightly stronger standardized loading than it did in the previous round, which is interesting, but all of these look like they are indeed related. We go through the same process. Corrupt and terrorizing and ignoring and terrorizing, same pattern. They want to be more related. In terms of model, saturated model correlations versus predicted model correlations and the discrepancies, still those two are the biggest problem. I went ahead and said, all right, I'll add those back in. Did the diff test, it's still worse. So in this case, it still doesn't support the idea of a higher order factor. Marginally, but it doesn't. So at that point I was like, I don't know what to do. I give up. I'm done. So, but point being, the process is exactly the same. Start with a saturated structural model, then see if the higher order factor model can recreate it adequately.
Wait, so the confirmatory analysis essentially was higher order with the error covariance would be acceptable, and this was no-go at all.
Well, it's close
Well,
to, it's close, but not quite. Yeah, so the CFA measurement model underneath it said that it was fine, and this one says it's not. So I would come to a slightly different conclusion. I'd have to go back and figure out why it's not fine and add more stuff. But if you have a higher order factor and it takes a whole bunch of other covariances to make it fit, you don't really have a higher order factor at that point. So, all right, so yeah, I'm calling it done. I give up. That's mine. I'm being honest. So yeah, questions about any of that? All right, then I want to change gears a little bit and head back to lecture 8, because I've had a lot of questions from folks about bifactor models, general factors versus specific factors and that kind of stuff, and so I wanted to revisit that idea and talk about, now that we have structural models with multiple factors, like what are some reasonable things to do to address, say, reverse coded items or stuff like that, and what are some not reasonable things to do. So starting with just item construction for a couple of slides and then models that would solve it. So I'm on slide 13 to start with here. So latent variable measurement models are not magic. They can only do what the data support. So to the extent that you have a design in which items measure different things in different ways, and you can pull apart if it's this thing or that thing, the model can support that. But sometimes you can't. So in terms of thinking about single items as well as pooling items together, these are principles that we went over like the very first week of class. A single item should cover a single concept with an explicit, clearly defined referent. It should provide response options that are applicable to everyone, and it should be not too narrow but not too broad, which is very difficult to do in practice. If we're going to be measuring multiple factors at the same time, so like subscales of a more general factor, you do not want to confound the stem of the item, meaning how the question is worded, the valence of the item, meaning whether there's positive or negative, and what the construct is. Fortunately, if you're willing to be a little bit creative, you can avoid having to reverse code and avoid having the two-factor type of model that it would lead to if you're willing to rewrite your items. I know this sounds controversial, but in the same way that research is supposed to be cumulative, right? Like people take like a finding and then they try to build on it. Like they try to add something to the design or add a different type of sample or something like that. And people mess with other people's research designs all the time. The same is true for items. If you have a scale that has confounds in it, there's nothing that stops you from trying to fix it and doing a study to see if it actually worked. I have a couple examples of that. So first, items that might have problems. These are items that I am actually familiar with on projects that I have worked on in the past. So how important is it to you on a scale of 1 to 5 that my family members have good relationships with extended family? And then in parentheses, trying to clarify what extended means, grandparents, in-laws, etc. In initial factor analyses of other items thought to measure family interaction along with this one was problematic. Can anyone guess why? I have a guess. I never really know why, but I have a guess.
Providing the examples is one thing.
Yeah, so what if you think it's important that you have good relationship with my parents, but I don't care about my mother-in-law? Like, how would you answer that question? Families aren't necessarily all cohesive, right? There may be factions, particularly with people that you marry into a family or leave a family through divorce. Yeah, so sometimes trying to clarify can cause confusion as to how someone would answer. There was another item on a subscale about, it was essentially resources, and that item is my family is physically healthy. That turned out to be not a good item either. I don't even remember what the scale was, but let's say 5 is like extremely important or something. Who's going to say anything less than 5? What kind of monster is like, nah, my kid can be sick, it's fine, I don't care. The same monster who's busy terrorizing and spurning and corrupting their child from the previous example. So yeah, this one has basically no variance. And if you don't have variance, you can't have covariance. So from that perspective, this would need a different set of response options potentially, where the lowest level would be super important all the way through completely essential or something like that. Or rewarding to make it so that it's something people could conceivably disagree with. To illustrate the idea of comprehensive response options, here is an item from a survey. What is the quality of the relationship that you have with your children? Nikki, how is your relationship with your children? Yeah. If you don't have kids, what are you supposed to say? Leave it blank? Think about what your latent children would be. Like, if I become a parent, I'm going to be awesome at it. Everyone thinks that before they are a parent, by the way. What if you have a great relationship with one of your kids and not the other? So if you're giving a survey to people for some items are not applicable, give them that choice. Otherwise, you don't know what they're going to say. You can actually use not applicable as part of the measurement model. So there was an example that I didn't have time to go over, but the code, and there's a video about it from a previous class, semi-ordered model is what it was called. And it takes a hybrid of a nominal model and a partial credit model and puts it together to allow a separate factor loading for not applicable within the item, and then treats the rest of it as an ordered category response. So you can see whether or not the fact that this person isn't a parent might somehow be related to the trait you're trying to measure. But not throwing it away is the key thing. Otherwise, you might have to do like a loop and be like, how many kids do you have? And then for each kid, answer this question, something like that. Here's another one. To what extent did others make it difficult for you to engage in various activities before your imprisonment? This is from a criminology sample. Do you have any idea what that question means? Who are others? Engage in what? And before your imprisonment, does that mean like just before you got in jail, like in your youth? I don't know.
There's not great alignment between to what extent and then the scale being a frequency. Like how frequently would be better.
So like this question I don't think is salvageable. Like this would have to be rewritten. What is the quality of the relationship? You could add a not applicable maybe and work with that. Here's one from a scale that I just completed actually as a favor to somebody. The item was, I rarely feel sad. And I'm not making this up. These were my choices.
That's a cognitive load issue.
So if I disagree that I rarely feel sad, I could disagree because I always feel sad, or I could disagree because I'm never sad. I'm not sure if I'm supposed to respond to the rarely part or the sad part or what. So yeah, this is not good either. So you can change these things. Here is a scale that I have had several students use, and I wish somebody would fix it. This is the difficulties in emotion regulation scale. It's supposed to be 6 factors, but this one in particular, lack of emotional awareness, falls apart, as does lack of emotional clarity when you do factor analyses on it. What I want to point out are 2 confounds in the way these items are written. Some of the items are reverse coded. In the lack of emotional awareness subscale, they're all reverse coded, whereas just 1 or 2 are for the other ones. None for this one, by the way. So if these items are correlated, I don't know if it's because of the common trait they're supposed to measure or a common wording in asking about that trait. It's confounded. The other problem is the difference in STEM. So I've included the item numbers here. So item 1, I am clear about my feelings, which needs to be reverse coded because the construct is supposed to be lack of emotional clarity. Number 2, I pay attention to how I feel. Number 3, I experience. Number 4, etc. And then all of a sudden, it switches to when I'm upset at item 10. So the first 9 items are starting from a perspective of, in general, how do I react to things? And the rest of it then switches to, when I'm upset, this happens. Now, I don't know about you, but I do not have the same level of problem solving and emotional regulation when I'm upset as I would like to think I do in the rest of my life. But this is an example of something that could be fixable. You could add when I'm upset to all the items. Put that in the instructions to say specifically think of when you're upset and answer these questions rather than having it mix concepts. We could try to word these so that they all refer to difficulty in emotion regulation rather than some of them being worded like clarity. So this could be fixed. This is a research study that somebody could administer both versions of the scale, randomly assign people to one version versus the other, and look at how the psychometrics change if you iron out these problems. This is something that could be done. I had a former student do something like that, and this was a paper that he and I and his advisor published in 2016. This was his SEM project. This is a scale about schizotypy, which is related to schizophrenic behaviors, but also has a little bit of like other stuff in it. And he noticed certain confounds, such that some of the items have the word you in them. Do you feel like people are talking about you? And some of the items started with I feel like this. Well, the relative balance of you versus I differs across subscales. And so some of them hold together better, I think in part, because of this distinction. So he decided to rewrite everything so that it started with you. Eliminate the confound. And what do you know? The psychometrics got better. Here's another one that I just discovered, and I thought it was brilliant. It's simple, but it seems like it would solve so many of these problems. Don't use the anchors to force yourself into a reverse coding situation. Rewrite the question. So they took a well-known Rosenberg, I think, self-esteem scale, something like that. And so like the original item here, I feel like I have a number of good qualities, or I feel like I'm a failure. If we're going to talk about self-esteem, I'd have to recode the failure one, because if you agree that you're a failure, then you don't have self-esteem. They rewrote the questions so that there was no distinction between positive coding and reverse coding. The answer choices have the full spectrum in them, from I'm completely a failure to I'm completely a success, or I have no qualities and I have very good qualities. They also did a version where they changed it so that it's still just one question with answer choices, but it's still the idea of the answer choices run the gamut from all the way negative to all the way positive. And what they found in an experimental design, where we're randomly assigning people to complete different versions of the survey and such, is that the original item format that required some of the items to be reverse coded ended up splitting into two factors because of that. And the rewrote ones did not. So I feel like there's a lot of psychometric work that would be considered potentially low-hanging fruit in terms of taking existing instruments that potentially have multidimensionality because of reverse coding and rewriting them and seeing if it makes it better, and seeing if it makes it better to the same extent for different kinds of people, for instance. One of the rationales that people give for reverse coding is to make your respondents pay attention. Like, they don't want people just saying yes to everything, right? And Nikki's shaking her head. Does that work? No. But you could compare different types of samples potentially, like a sample maybe where you pay them to do a really good job versus a sample where you don't, or, there's other kinds of manipulations that you can use to induce attention or lack of attention. And you could see to what extent, these are differentially impactful. So there's a lot of work that can be done on these sorts of things. But I want to encourage all of you who are working with scales that fell apart when you did your psychometrics to think that you actually have some autonomy. You can fix it. And that process of fixing it could potentially be not only publishable, but could help other people at the same time. So there's my soapbox. You don't always have to stick with the same items as they're originally done, but anytime that you do change it, then you would have to make sure that you report psychometrics on your changes, because it isn't the same scale anymore, but maybe that's a good thing. All right. So in terms of if you're stuck with items that are already in this type of, some of them have to be reverse coded, what can you do about that? So there's basically 3 different choices for how you can build extra relationships into your model if you can't rewrite the items. The obvious one is an error covariance. Like we just saw with the lower order factors or with the items, you can allow a pair of variables to have an extra relationship beyond what is predicted in common by the factors. These do not lend themselves to evidence, though, to make arguments about why that error correlation needs to be there. You just know that it does. You can also estimate separate latent factors for every unique combination of way of asking the question and the trait that it measures. So this is the approach that I took in example 4. I had 3 items that were positively worded in measuring forgiveness and 3 items that were negatively worded, and I fit 2 factors because that's what it took. Now that's less than ideal if I still want to talk about forgiveness as a unidimensional construct. Fitting separate factors for the method and for the trait then potentially induces a lot more ambiguity as to what you would then find, how these relationships, how these factors predict other things. The middle ground, and the ground that I think is probably the least understood conceptually because these models are so easy to fit, is bifactor models or method factor models. And this is the idea of adding extra uncorrelated factors that soak up covariance due to common stem, reverse coding, and other kinds of things like that. It's also the basis of what's known as a multi-trait, multi-method model. That's in your textbook. One of the intermediate chapters talks about that one. What I would encourage folks to think about in fitting these models, which is what we get to talk about next week, it looks like, is trying to use loading constraints to help support your desired interpretation. So for instance, if I think that I can fit a method factor for all the items that are reverse coded, in order for me to say that that is only what that factor is capturing, I would potentially want to show that all of the items loading on that method factor have equal factor loadings. They're all equally reverse coded, right? So to the extent that some of the items have a lot stronger loadings on the method factor than others, or God forbid to the extent that some of them are backwards, negative and positive loadings, that's not just reverse coding. I think it becomes a lot harder to argue what that factor is if it has these distinct patterns of relationships. So I've got some examples of how I've done that in the past and how other folks have approached that problem as well. But it's 3:11, which means we don't have time to talk about those today. So that's what we'll pick up next time. Let's see, Monday night is due your formative assessments. So we will talk about that on Tuesday as well as this, and I will let you know when new material for next week is posted. Not much, since we're running out of time, but some. The good news is that once you get the measurement part, the SEM part is very straightforward. I keep saying that, but it's true. Because there's very few things you can put in. Like, either you have a direct path between your factors or a correlation. Like, there's not a whole lot of complexity there. The hard part is building the measurement models. All right, questions? No, we're out of energy. 1 week to go, folks. Thanks for being here. I hope to see everybody next week. Let me know if you need anything. I'll let you know when your assignments are graded, when there's more stuff for you to do, all that kind of stuff. So, all right, peace out, everybody.